Hi everyone. The next topic is the language of PDA. So the language of PDA is nothing but, so how we can tell a language is accepted by a PDA. So what is a PDA actually? It is a mission. So it accepts a grammar a CFG. So now the language from the CFG, how a PDA can accept. Okay, so there are two ways to define whether the language is accepted by the PDA or not. One is a final state accessibility, the second one is the empty stack accessibility. So let's say one by one. Final state accessibility. Final state accessibility is nothing but, so if PDA accepts the input string and it reaches the final state. Okay, if a PDA accepts input string and it consumes entire string, and if it reaches the final state, then we can say that the language accepted by the PDA in the form of final state accessibility. Okay, so like this we can define the language accepted by the PDA in the form of final stack. Okay, so this is the PDA that we know already. We discussed formal definition which consisting 7 tuples and all. So now, so language of PDA can be defined as a W. W is any string from the language. A Q naught is the initial state. W is a input string that we are giving to the PDA, and I is nothing but stack symbol. We can also use a Z. We can also use Z not like that. Here we are using I. So, and this is nothing but turnstile notations. Star means a set of moves. So by consume from initial state, by consuming input string, so with the stack symbol I, we can f is nothing but a final state. So we reach the final state and we have nothing. We consumed entire input string, that is nothing but epsilon, and x is nothing but so there may be symbols in the stack or not, that is not required. Our requirement is, so the string should be epsilon, that means there is nothing in balance in the string consumption, and we have to reach the final state. That is important here. So f is nothing but a final state. Okay, so the language of PDA can be defined like this. Okay, so language of PDA can be notated as L of P. So simply, so this transmission ID with the turnstile notation can be used for that. Okay, hope you understand. So here you observe from Q naught, we starting state to final state we reach, and with a string W, when we reach the final state we don't have any here. Okay, epsilon is nothing but nothing in the input string to consume. So that is about a final state accessibility. The next one is empty stack accessibility. So if you say that language is accepted by the PDA, so with the help of empty stack, and the way is nothing but empty stack, that is nothing but on reading the input string from initial configuration for some PDA, the stack of PDA gets empty. So whenever the consumption of input string completed, if you look at the stack, there is nothing in the stack. So in the previous case, there may be or may not be data in variables in the stack, that is not issue. We have to reach the final state, but here we have to consider the stack. So there is nothing in the stack if we after consuming the entire string. Okay, so that can be defined like this. Okay, this is a PDA with a set of 7 tuples and a language of PDA with an empty stack. So W is nothing but a string from the language. Q naught is the initial state. W is the input string. Again, we are consuming input string. I is nothing but stack variable. Okay, so after set of moves, this is nothing but a turnstile notation moves. Okay, so maybe we are in the final state or not. That is not a question, not a point here. Okay, so previously we should reach the final state, but here, so we reached a final state or not, that is not a point here, that is not important also. So when comes to the input string, entire input string should be consumed, and this is the thing here. So what is there in the stack? Here nothing is there, so that is nothing but emptying of stack. So the stack is empty after consumption of entire input string W. Okay, so maybe we can reach or not final state, that is not important here. Okay, so PDA, the language accepted by the PDA for the by the full empty stack accessibility can be noted like this: n of p. So here the n is nothing but a null stack, null stack or empty stack, whatever. So n of p is nothing but a null stack. So this is the representation of empty stack accessibility through the IDs and turnstile notation. Okay. So the language of PDA deals with nothing but there are two ways to accessibility language by using a final state, or the second one is a empty stack, not null stack. Okay. So if you observe the things here, so PDS accepting by a final state and empty stack are equivalent. Okay. So when we construct when we try to understand a language accepted by the PDA, it may be a final state or it may be an empty stack. Whatever may be the way, we can say that the language is accepted by PDA. Okay. Now we can also have an option here. So the PDA accepting by final state and empty stack both are equivalent. We are trying to say that. So then that can be proven also here. Okay. So let's take a final state PDA as a PF and empty stack PDA as PN. Okay, so these are the test set of tuples we define in the PDS generally. So if empty stack PDA is equal to the final state PDA, for every PN empty stack there exists a PF. So if both are equal, so if PN exists, there also an exact PF. In the same way, if PF exists, that means a final state PDA exists. In the same way, null stack PDA also exists. Okay, we can, for the same language we construct PDA empty stack, PDA final state. We can say that those are two equal. So this is another way to define accessibility. So what we discussed, there are two ways to to say language accessibility, right? So now we can also convert from empty stack to final state or final state to empty stack. Okay, so from one way of language accessibility to the another way of language ability, there is a possibility of conversion. Let's discuss those. So first one, N stands for null stack, right? So PDA with empty stack can be converted into PDA with a final state. How it is possible? So whenever PN's stack becomes empty, so make PF go to a final state without consuming any additional symbol. Okay, so now we are trying to show. We are trying to show that the language is accepted by a empty stack. PDA actually PN here. Okay, so whenever we did with that means language is accepted by PN. So maybe we can reach a final state or not, that is not an issue. Okay, so when we are in the when we empty the stack, so we can't say whether we reach the final state or not. So to reach a final state directly, so we can use a new symbol x0 which is not there in the tau. It is not actually stack variables, it is a new variable. Okay, so to show that, so Pn is we can convert into to PF, both are similar actually. So but from PN to PF conversion we take addition variable x0. So if you observe the diagram you can easily understand. So we start the PDA for accepting the data. Okay, so in general in early classes what we inserted actually Z0 we inserted initially to the stack, but now so to conversion PN to PF what we inserted is x0, a new symbol into the stack. Initially we push x0 into the stack. Okay, so if you reach a consuming of input to string and empty stack when we reach, that means Z0 we reach. So Z naught we reach means we consume entire string. Okay, so we left over with x naught, right? So directly from x naught we can transform it to the uh, final state, so by using epsilon transitions. Okay, I'm repeating once again. Now the thing is, we have to convert a PDA empty stack to the PDA final state. How it is possible? So PDA empty stack means we consume entire string, we are at the empty stack. But there may be a chance to reach the final state or not. If reach, it is good. If not reach means we are at the some other state. So but we have to reach the final state, that means the conversion is required, that only, right? So for that reason we insert x naught into the stack initially before z naught. Z is not is a stack variable, belongs to tau, but whereas x naught is not belongs to tau. First you should push x naught into the stack. So whenever we consumed entire string, when we reach the z naught, so we can directly transform it to the final state by using epsilon transitions. Okay, so both is actually happening here. So we consumed entire string, we emptied the stack. So that means we are at PDA empty stack. And by with the help of epsilon transition, we directly reach the final state. That means a PDA with a final stack accessibility. Those two are possible here. Okay, what is actually happening? So PDA empty stack can be converted into PDA final state. Okay, so this is an example. So matching parenthesis. So this is related to emptying of a stack, and here we convert empty of a stack into the so final state by inserting x naught initially into the stack. Before z naught we insert push x naught into the stack. Okay, so later on we directly we pop the x naught by using epsilon transitions, and we finally reach the PF. Okay, so to understand this example, you already need to know the how to construct a PDA. Okay, so I'm discussing about PDA language accessibility from empty stack to final state conversion. Okay, so again and again constructing PDA is a difficult. And so from final state to empty stack, so there is a possibility to convert final state PDA to the empty stack PDA. How it is possible, let's see. So the idea behind is, so what is a PF actually? We can consume entire string and we reach the final state. But here there may be empty stack or not. Okay, so when we reach the final state we can check whether stack is empty or not. So we can empty the stack also, then the final state PDA become the empty stack PDA. Okay, so whenever final state PDA reaches the final state, just make an epsilon transition into a new end state. So clear out the stack and accept the language. Okay, so but there is a situation, if the if PF is designed and PDA final stack is designed such that it clears the stack midway without entering a final state. Before entering the final state, if the stack is already emptied, what will happen? So to solve this kind of problems, so we add x naught. That means a previous thing what we did, we add x naught to the stack. Whenever we find x naught, we directly go to the final state. That is actually happening here. We combining both. Okay, so we are in the PDA final state. After consuming entire string, when we reach the final state, by performing epsilon transition, we can do the stack empty. So just like it, like a vice versa. Ante manam final stack after entire input string ni కన్జ్యూమ్ చేశాక ఫైనల్ స్టేట్లో ఉంటుందా, నల్ ఎంటీగా ఉంటుందని చెక్ చేసుకోవాలి. ఫైనల్ స్టేట్ రీచ్ అయినా యాక్సెప్ట్ అని చెప్తాము, నల్ ఎంటీ స్టాక్ ఉన్న రీచ్ అని చెప్తాము. ఒకవేళ ఫైనల్ స్టేట్ని రీచ్ అయ్యాము బట్ స్టాక్ అనేది ఎంటీ లేకపోతే ఏమవుతుంది? సో ఎప్సిలాన్ ట్రాన్సిషన్స్ని యూస్ చేసుకొని స్టాక్ని ఎంటీ చేయాలి. అదేవిధంగా ఎంటీ స్టాక్ అయిపోయింది, ఫైనల్ స్టేట్ని రీచ్ కాలేదు అని అంటే ట్రాన్సిషన్స్ని యూస్ చేసుకొని ఫైనల్ స్టేట్ని యూస్ చేయడం అనమాట. అంటే ఒక దాంట్లో ఉంటే ఇంకొక దాంట్లోకి వెళ్ళడం బై యూజింగ్ ఎప్సిలాన్ ట్రాన్సిషన్స్ కావచ్చు, లేదు అని అంటే ఎక్స్ఎన్ఆట్ అనే న్యూ స్టాక్ వేరియబుల్ని యూస్ చేసుకొని కావచ్చు. ఓకేనా? సో అర్థం చేసుకోవడానికి ట్రై చేయండి. సో దిస్ ఈస్ అన్ ఎగ్జాంపుల్ ఫర్ ది ఫ్రమ్ final state to empty stack we convert. So if you have still any doubt, you can visit the site here. Okay, and this is a note from the book. I defined this one. Okay, hope you understand the language of PDA. The language of PDA is nothing but whether the language is accepted by the PDA, that can be shown. So in the finite automata also, how we can say a string or a language accepted by the FA? When we reach the final state, then we can say the string or a language is accepted by the FA. The same thing we can do here. So here, if the consumption of a string reach the final state or empty stack, then we can say that the string is accepted by the PDA. So but here there is a chance conversion between from PDA empty stack to the PDA final state, as well as PDA final state to the PDA empty stack. How it is possible? With the help of x0 is a new stack variable, we can use it. By using this, we can convert from empty stack to the final state. In the same way, final state to empty stack, we can reach final state from empty. We can empty the stack with the help of epsilon transitions. If there is a case when we before reaching the final state in the PDA, if the already empty the stack, if we already empty the stack, then what will happen? Nothing will happen. We just use the x0 as a new variable. If you find the x0 in the stack, we can directly go to the final state. Okay, so that is about language of PDA. Thank you.